Do you guys have a light weld now?
Well, one of our company has already bought the laser source 1 years ago,
Okay.
so we manually use it.
Okay,
All right.
awesome. That's great then.
So, so you plan to go through the robot and then go through the touch sensor thing, right?
Yeah,
Yeah.
yeah.
Okay.
So I'll zoom in here when I'm showing you the robot, the tablet and the program and all that. But yeah, so I'll introduce myself. My name's Evan, and I'm over here at Sarah Laser in California. So I've been working on the team that's been doing the integration with the LightWELD and the Fanuc CRX robot. So what you see here is the CRX 25 IA collaborative robot from Fanuc. So this is their largest offering here. Has a 25 kilogram payload. You can see the size of it when I'm standing here. It's when it extends out, it goes pretty large. And then right here at the moment, I have a LightWELD 1500 XC attached to this mount. Let me see if I can let me rotate it around so you can get a better view of how this looks on here. Good. I'm just spinning it, and then we also have the Servo Robot Quick Spot set up on here, which we've recently got integrated into the system. So yeah, you could see the LightWELD gun here in the cradle. This cradle is manufactured by IPG for us with this system. It's on the other side, but there's two buttons here that you can use and program to do different operations. I don't typically use them myself, but you can use them to put the robot into like free mode where you can move it around by hand and change what type of movement it has when you're in that mode. Here's the quick spot sensor here on this fabricated bracket. And the quick spot's going to be used to, you could teach it where to search and in what directions to search by setting up a touch frame and have it look for the edge of a part, and it's going to sense that edge based on a difference in distance. So essentially, if I had a piece here and then a piece on top, I could give the robot a reference distance on when to send an input to the robot controller based on the change in height in part. So if you're doing an outside corner, you'd sense in a different orientation. At the moment, my setup here is for a lap joint, so I'm basically sensing the distance as the laser hits that top piece of metal. And there's a lot of adjustment there and different joint configurations you can do with that. But yeah, I have it set up as a lap joint here. But yeah, so I'll get started on talking about how we program this robot. So using our LightBOT software, we're able to control the LightWELD. There we go. We're able to control the LightWELD by using socket messaging from the Fanuc robot controller. So during a weld, we can change anything from the laser power, laser wobble. We can select preset modes, custom parameters, and so on and so forth. So you're not just limited to what's set on the front face of the LightWELD. You can actually change during the program. And there's icons that you can drag and drop onto the timeline to do all of that. But simply put, this system, you can either manually manipulate the robot like this. I can manually manipulate the robot to find positions. And typically I do this kind of thing to get my rough program set. And then I go back and touch up by using the jog feature, which you saw me do a minute ago when I spun that axis. And so I can jog in different directions. I can move in relation to different coordinate systems. So I can use the Cartesian system at the face of the robot. I can move in relation to the tool coordinate system, which I set up when I initially set up the system. And I can also move in relation to the tool frame of the actual servo robot so that I can align my searching parameters as far as like where the laser is going to be at what height when it searches and all that stuff. So that's kind of how you go through moving it. And then once we've you know, got our position that we want, we can then zoom in here. We can then use this the teach pennant to go to this programming screen, which has various options for icons. We have one for motion, which will be linear, joint moves, circular moves. Control, which can call up macros, subroutines, put a pause, flags, jumps, and labels and all that. We can activate digital outputs through here, and various other things. My favorite feature to use is, you know, once I've been using it for a little bit, is I can use this history, and then it shows me the icons which I have used most commonly. This is the screen that I typically stay on, and these are the icons which I typically use in my programming. And these are set program, linear motion, laser on, laser off confirmation, circle arc, circular, weight, and tool frame select. So this is kind of how I go about doing my program. And you can see the programming method is as simple as just dragging an icon into your timeline, dropping it, and then making adjustments to that icon in the details menu. So I can select any of these icons which I have placed in this program and adjust the positions, the parameters, speeds, and so on and so forth. Now, when you're using the Servo Robot, there is some, there are icons with the Servo Robot, you know, for doing the search. But what you'll have to do is, you know, manually input what direction, or the way that I did it is I actually made my program in the legacy mode, which if you're familiar with robotics with Fanuc, you might be even more comfortable doing this, where you can edit your program line by line. And this is how I actually programmed this quick spot, and it makes it a little bit easier because you don't have to manually type it in. You can search through these lower menus here and find the option you want and select it. Yeah, so
Can I ask a question?
yeah.
Well, the time that you use the TP programming for the vision section, it is possible to change it for the timeline. Well, using the icon, or
Yeah, so
Well,
once you've if you've programmed it in legacy mode, then you can go and you can make adjustments through the timeline. And you can program the quick spot through the timeline, but you'll have to know what text to input in the additional motion for the search.
yeah.
So like, right, where did it go? Right here it says I'm in the zoomed out, didn't I? Okay. You can see here I have a position. The highlighted blue one is the position that I'm currently looking at here. And you know, it traps the coordinates in this position. And then when I wanted to do the search, so long as I have the search activated, I can then put search in the X minus direction, and it knows to search in X minus until it reaches that reference distance, which I've dictated the Servo Robot to look for.
Okay.
Yeah, so and basically that's kind of the gist of the programming. There's a lot of things to talk about as far as like different menus and all that. But as far as demonstration purposes goes, you know, that's the simple gist of it, is you drag and drop icons and edit data within those icons to create your program. Yeah, and so what I have here, the way that I've set up this Servo Robot to do this weld is I've created a master part. So this is a part which will sit on my fixture table in a certain position, and this is the perfect part, right? So when you first set up the Servo Robot, you want to make a perfect part and essentially teach the Servo Robot where to look and how to adjust based on this perfect part. So that's what I've done. I've gone and programmed with this. And then what I can do is then take another piece, such as this one, and run a test weld. And what I've done here, and I'll do it live for you also so you can see it actually happen. But you see how this is quite a bit different than my master part as far as like how off this plate is compared to this one.
Yep.
So the servo robot will basically go with its laser and its distance sensing and detect. I have it looking for this edge, this edge, this edge, and this edge, and it'll detect that here. And then because my plate was off, it will then shift those coordinates in order to move my weld to correct for the misalignment of this part here. So that can be done on, lap joints, outside corners, inside corners, T joints, stuff like that. It doesn't work particularly well with lap or butt joints because there's no height difference there. But yeah, so that's kind of what it does is it basically reads the edges of this part, and then based on how far off from its master program it is, it then makes us a program side by side with different coordinates to then shift the motion. So what I'll do here, if you're ready to go and to watch this, I'll run a part that's set up properly so that it's matched to my little fixture table jig here. So I'll put my bottom piece on here. I've marked the table where it's supposed to be. And then I'll put a top plate on here. So this is how that master part was programmed, and I'll run this, and then I'll set up another one where I shift the top plate just to, demonstrate how it will correct for that misalignment. So I have my program made here, and I'm just going to throw on my welding helmet and run this weld here. I'm going to do a dry run first just to verify that everything is going to work properly and make sure I'm not going to crash since I just set this up for the day. All right, so the robot will come down. It has a little red dot. Not sure if you can see the red dot, but it's searching from here in this direction until it hits the edge of the part. Now it's searching here. And right when it senses this height, it's going to, collect that data and then adjust the program. So now it's coming down towards the part. It's done a tool shift now. So now it's using the LightWELD gun as the tool frame. And it's traveling right along in that lap joint. You can see the laser beams right there, nice and tight in the joint. And then I'll go ahead and weld it so you can see that. So now I'll deactivate dry run option. And we'll weld it again. And you can change the speed of this search. I'm running it at a fairly slow speed at the moment. But yeah, you can change how far it will search. So if it doesn't detect something within a certain distance, it will fault essentially. So, means the part's not there or it's not within the tolerance range that you set. All right, so you can see that it has welded right there in the seam, and that's because the master program was perfect. So it, it didn't have to do a shift there. And then I'll run another one where I'm going to misalign this top piece of this plate, which would, simulate, for instance, if you had a piece of slag on your jig or something, and then it had to make a slightly different path to make the weld. So what I'm setting up is essentially I'm going to set it up, you know, with an angle on this top piece, whereas before it was perfectly straight. I'll put this in the correct position, and then I'll kind of put this in some random angle there. Can you tell that that is an angle? Excuse me. So I'm not changing anything as far as the program goes. This is the exact same program that I'm going to just run again. So I will press play. It's going through and reading the distance. I'm not sure how good you can see that red spot, but it's going through and measuring there. And then it's going to run this weld. So instead of following that trajectory of the master program now, it's now following the trajectory of the part, which has it has made an adjustment in order to compensate the error in setup. All right. So now you can see that part was quite a bit off from the original, and it still managed to put the weld right there in the joint, just how it should have. So that's pretty much how the servo robot works. Again, if with this joint configuration, I had it searching an X minus in 2 different positions and then Y plus in 2 different positions to find the edges of this top square piece. But based on your configuration, if it's a T joint, an outside corner, an inside corner, you're just going to have it search in different manners to sense the joint, essentially.
Okay.
Hey, did you go through the different icons that we have, the LightBOT icons?
I went through a couple of them, but I'll
Yeah.
go through in a little
Let's
bit
go.
more detail here. So yeah, let me show you the complete list of the LightBOT icons. So once again, I'll go into the programming area. I'll go to plugin, which is where we'll find our LightBOTs, because that is a plugin that we will have installed in the system. And we have a lot of icons. You know, you may or may not use all of them. I use just a very small amount of them, but you have a lot of options here. So you have icons specifically for laser cleaning, which allows you to adjust the parameter of a cleaning program and save that as like your own laser cleaning preset here. You can do laser off, laser on, laser off.
Can you hit those and show them? Show them what's.
Yeah.
Yeah.
Yeah. So the laser on, I'll go to the details of it. In the laser on icon, you can select gas pre-flow and power ramp up of the laser. So for instance, if you notice that the very beginning of your weld is a little bit too hot, you may have too long of a ramp up delay in the program where it waits for that laser to ramp up before moving on. So you can adjust how long it'll wait for that ramp up. So I have the ramp up set very quickly, so I don't get a hot spot at the beginning. This is 20 milliseconds. So it fires the laser and very quickly moves along. You may want to, on a thicker material, have a little bit more energy input before moving on to establish the weld better. And then in that case, you would just increase this power ramp up value along with the power ramp up on the actual weld program. And you can do that here through the LightWELD interface, right here on the tablet, where we can go to the right over here, you can adjust the actual ramp up time of the laser. Whereas in that other menu, you were adjusting how long the robot waits for that ramp up to happen. And this LightWELD interface allows you to adjust many things. So you can see right now we're on preset mode A2 for this stainless plate. I can choose any of the factory presets, adjust the power, the wobble, the pre-flow, ramp up, ramp down, and if you're going to use wire feeder or not. And you can also, you know, create your user settings or custom settings here. And the custom settings allow you a greater range of control. You know, not only allowing you the adjustments that you can do on the front of the light weld, but also you can change between continuous wave, tack welding, which is like a timed weld. You also use that for spot welding. Modulation, where the power is, you know, high, low, high, low. It's like a pulsing action, limits overall heat input, and allows you to weld very thin materials. With the modulation, I've managed to weld down in the 5,000ths range for stainless steel. And that is still tricky, but just to let you know kind of what you can push this machine to do, despite that it's advertised that, you know, welding from 1 to 4, 1 to 5 or 6 millimeters, you can push those boundaries by making custom settings like this. There's also a newer feature that's real handy, called power compensation. So you can see down here, and where it's red, it says compensation, and I have it currently enabled. And I have a percentage value input here of 30%. And what that does is it allows you to focus the energy more in the root of the weld. So essentially that laser is wobbling side to side. And when it hits the edge of the wobble, there's a dwell period, right? Very quick, but it has to stop and go the other direction. So the edges of your weld with no compensation will sometimes be over penetrated as compared to the center of the weld. Power compensation is a subtractive adjustment where it will subtract power based on that percentage you enter from the edges of the weld, so you can focus the energy more towards the root. So you don't always need that, but it helps in situations where you don't want to get burned through on the sides and you want to ensure that you have the most penetration in the center of the root. So that's been a real helpful addition to the LightWELD system. They just added that recently, and I believe all of the current LightWELD systems are updated to have that. And if you bought your LightWELD a year ago, it probably doesn't have that, and I do suggest doing an update on your LightWELD, you know, reaching out to IPG, or I think maybe if you reach out to us, we might be able to help you with that, and getting that power compensation feature, because that's really helpful.
Okay. Oh, good. I'd like to know how much time does it take you to set up the camera and the servo robot system?
Yeah, so the setup involves you know, putting in some terminating some connections into the Fanuc controller, and you know, just running your wires and you know, bolting on the mount, managing your cabling for it that goes up around the arm of the robot, just like the LightWELD cord will. So as far as once you've got everything ready to install, it shouldn't take more than a few hours to actually install it. As far as programming and dialing in the settings for the quick spot from Servo Robot, you will, you know, it might take a little bit of testing to get your settings just right, and maybe, you know, a little bit of time to kind of set up, you know, your touch frame, which is, you tell the Servo Robot its own coordinate system from which it searches from. But I'd say if you had a day, you could get this set up and running.
Okay. So that's nice.
As far as getting like super familiar with using it, you know, maybe it might take a little bit longer, but it just depends on how quickly you pick up on that kind of stuff.
Okay. Mainly we weld backward with the IPG system. Have you ever done some welding tests using the forward direction for weld?
I don't know personally about the difference between the pulling and pushing angle with the laser. I know the optimal angle that they recommend to use with the LightWELD is based on you know, is more based on the handheld use of it. It's easier to pull than push when you're using it by hand because of the friction on the surface material. And then also the gas that's flowing out of the nozzle You know, will provide a better gas coverage when you are leading the weld, because the gas will be flowing over the existing weld. Whereas if you're going this way, the gas is pushing that way, but your hot material is then going behind you. So there may be some differences there. However, there also may be solutions around that, such as there is a, I'm going to grab this other piece here. This is an optional accessory that you can run, which is similar to a gas lens with TIG welding. So this is something that IPG offers. Essentially, it has an auxiliary gas hookup, which you tie into the line going to the LightWELD head. And then it has some laser drilled mesh here, which gives a nice laminar flow over a larger area. So you might be able to, you know, accommodate the gas flow despite your direction with this, because it gives a lot better gas coverage. Typically, this is used with people doing titanium welding with this.
And that kit, you create it or you buy it, or?
IPG, the manufacturer of the laser, they make this and offer it. It's for sale on our website.
Okay.
But yeah, it is not made by us. It's an IPG product.
Okay. And how do you jump the signal to, because there is no contact between the gun and the part. So for the security, there is signal that you have to jump to make sure that you can weld with it.
Yes. So what we're using is something that we've had developed for our software, which is called Fusion Lock. And we realized that with really simple geometries, you can touch the surface, and you know, it's easy to program and all that. But once you get into a more complex geometry, it becomes very difficult to maintain contact and still weld the part. So what we've done is we have a relay and an output from the robot being used to close the contacts on that relay. And when you're on the laser on command on this program, you essentially will set Fusion Lock to activate. See right here, this where the checkbox is, enable Fusion Lock, and that closes the contacts of the relay once the laser on command is activated. And then on the laser off command, it will automatically disconnect that connection. You must make sure that you put the laser off command in the correct position. So for instance, you want to make sure you don't put your laser off command over here, because it may fire the laser for an extended period of time. So it is you just have to be conscious of that fact that you are you know, responsible for putting the positions in the right spot at that point. But you can also use this with the touch contact if you wish. You don't have to use the Fusion Lock if you don't want.
And then explain how that's kind of different if you're wire welding.
Yeah, so when you're wire welding, what we do is we have the wire retract before the weld begins. You teach the point of weld with the wire at the correct distance, and then when it comes to weld, the wire is retracted. It will come down to its position, feed the wire out at a slow speed, and then once it touches the surface with the wire, it senses that touch contact, and then it immediately switches over to firing the laser and increasing the wire speed. So for the wire welding, we use the wire as the touch, and it ensures that we are, you know, having the wire incorporated with the weld the whole time, and that, you know, we're at the right distance and all of that.
I ask those questions because we intend to use the Servo Robot Power Cam 4.0 to do some seam tracking. And I know it is not usual, but I will try to do some adaptive welding with it. So I know that there is 5 program in the welder. So I intend to use them like a stairway, you know, to try to create some weld with different parameter during welding. I know you can change the parameter, but with the camera, if there is any difference in the gap, I would like to be able to modify the weld parameters. using the adaptive welding, and the camera will be placed just below the torch. That's why I was asking if you weld backward and forward with it, because I will have the obligation to weld in the forward position using that camera.
Okay. Yeah, you can definitely weld forward and backwards with the light weld. One thing to do is if you have one, I have one of the nozzles which doesn't have a set direction. I'm using the round one right now. But if you have one of the nozzles which is intended to go in a single direction, what you can do is you can simply flip the nozzle 180 and just have the gun travel in that direction, and that way you should get better gas coverage like that. Yeah, so we use, you can probably tell by looking at our gun that we're not using it in the same orientation that you would use it by hand. Where we've inverted the gun essentially, so we are kind of welding with it backwards. Typically this, we're welding this way most of the time, and the gun is essentially backwards. So you can do that. It's just a matter of the orientation of the nozzle and which direction the wire's feeding. And yeah, but you can kind of tailor it to how you need. You just have to do a little testing on what works and what doesn't. But typically we weld in this direction, but you can definitely go that way.
Hey, did David set the one up with the wire feeder?
I can show him the wire feeder. We don't have a program set up for it.
Okay, maybe just show him on the gun.
Yeah, I'll show you the wire feeder on the gun. So you can see here, this is the wire feeder conduit, that white. Let me hold on. Give me a second. Let me step over here. And then let me move my camera so I can see what you're looking at. Okay, so this is the wire feeder conduit. We have found that the best solution is to use a tool balancer to manage the wire feeder conduit. So we have the tension on that device set to where it has like a neutral balance. And right now we're just hanging it from this post. There's probably a more elegant way to do it. And then the wire feeder conduit will travel down to the gun, just as it would normally. And you can see we have the wire going right to the nozzle here. One difference here is this clamp is actually at a different angle than the factory LightWELD clamp. What we found for accuracy with the robot, the robot isn't like a human where it can, you can look at it and immediately see, maybe the wire is going left or right and compensate. It's going to run that program how you've taught it. So what we found is a lot easier is kicking this angle forward more like this, and it puts the wire at much shorter of a distance, so it's less likely to want to sway side to side. So this is a custom piece that we have made that we provide with the LightBOT system. But yeah, so this is essentially how the wire feeder works here. And we just kind of put the wire here, but how you manage the wire, like for instance, if you had the wire coming in from this way, you just mount it in a different way. Typically we just use Velcro straps and zip ties like this to kind of maintain our or do our cable management there.
Yeah.
And this mount you see here was the early prototype, so it's slightly different than what you'll actually get. We just use this one for testing.
So this is not the basic holder?
The actual holder is a little bit different. So if I zoom in on this one, it's more refined than the one that I just showed you on the wire feed one. So you can see that one's just a little bit different, a little bit. The angles are just slightly off and compared to the original mount. So that one that you see right there is what you will receive. And if you choose not to use those buttons, you can see the illuminated buttons there. If you choose not to use those, like I personally don't find myself using them very often because I I just use the tablet to make those controls myself. So yeah, if you choose not to use these, you can actually eliminate this section of the mount and bring this farther up by, what is this, 5 or 6 inches, to kind of shorten up your tool setup there. Just in case that gets in the way. You know, the mount is something that's fairly universal for most applications. We found that it works for almost everything we've done, but there may be a situation where you may desire to move this in a different way, and you can modify this however you need to fit your application. You'll just have to reteach the tool center point because it will vary if you move it.
Yeah. Okay.
And then if you do want to use this by hand, if you want to go back to like doing handheld welding, maybe just to do some testing or something like that, you can unclasp. It's a little hard with the servo robot hooked up. I'll need to remove this wire, but there's a clasp here, and then this little side piece that you see right here will flip open, and then you can pull the LightWELD gun out. So when you do that, you can then take the gun off, remove your cable management, and then switch it back to handheld welding mode as opposed to co-robot welding mode. And the difference there's a switch that's a little bit out of sight here, but I switch it from handheld to cobot, and handheld mode allows these triggers to actually control the LightWELD. Cobot mode uses signals from the Fanuc to control the LightWELD triggers.
Okay. What is the accuracy if you use the gun manually and you replace it? What is the accuracy? The tool holder is accurate to keep the same position?
It should be very accurate. It fits tightly into here, but I would recommend, if you did that, to go back and just verify that your positions are close. You may have to do a slight amount of touch up, but it should be very close. And if you did need to do a touch up, it would be essentially reteaching your tool center point positions, and it will correct, the program is based on the tool center point. So if you correct your tool center point position, then the program should also be adjusted based on that.
Okay. Okay. You have any question, Felix?
No, not for now.
It's interesting. So do you weld different material?
Yeah, we've welded all different kinds of materials. So far, the majority of people that are using the LightBOT system that we've created here are doing steel and stainless, although there has been some that are doing aluminum. But you're not limited to the materials that you're going to be working with. It's more dependent on what LightWELD you have. So if you need to do brass or really thin materials, or you need extra penetration, you'll want to have the XR system of LightWELD. This one's the XC, and it works on a great variety of materials as well. But as far as using the LightBOT, it'll work with whatever you put in front of it.
Okay. Well, it is the XC that we have bought. So.
Yeah, and what kind of materials are you working with? I think I saw a quick picture. It's like looks like maybe a thin gauge box or something like that.
Well, yeah, we mainly, with this equipment, we'll mainly weld 16 gauge, so 1.5 millimeters to 1.2 millimeters.
Okay.
So we will mainly weld those thickness with the robot.
Okay.
So we will weld some kitchen sink corner.
Got it.
So,
yeah, that's no problem. We've had quite a few customers bring to us kitchen sinks and stainless countertop type stuff, and we've welded it with all the different kinds of LightWELD. So
yeah, so really interesting. I would like to know, did Glenn is online? Yeah. Glenn
is here. Yeah.
Yeah, I'm here.
Okay, I would like to know if we send you a PO, do we have to send you the welder and all the equipment for the interface?
No, we can do that all. We can do that all in the field.
Okay.
Yeah.
Yeah. The only thing we'll have to do is have you do an update on your LightWELD in order to allow the Fanuc to communicate.
Okay.
But you can do that at your location. We can instruct
Yeah.
you how, or it may be something where we
Actually, I
have
think
to.
Carl will probably do it when he do the install.
Oh, yeah. Carl will do that for you on site.
Okay. And your lab is based in California or?
Yeah,
Yeah,
Anaheim,
we're in
California.
We have another sales guy in Michigan, and then the robot installer, actually, that's Carl. He comes out of Texas. So we have 3 locations.
Okay. Okay. So thank you for the demo. I have a better understanding right now. I read a lot on the process and all I can found on the internet. But there is nothing better than a nice demo. So I can see you have 2 robots, one with a wire feeder and the other one using only the laser for welding.
Yeah, we typically have them set up like this just so we can, be ready for whatever comes our way if somebody brings a part in and we need to do some testing on it.
Okay. So you have the XR as a welder or?
We
The
do have
XC?
an XR as well. In this booth, we actually just have the XC on this robot and then the standard LightWELD on the other. We have the XR in our handheld welding area, which is just on the other side of this room.
Okay.
We've used all of them, yeah.
Okay. Well, I really appreciate the demo.
Thank you.
So I might have more questions maybe a little bit later. But as I'm concerned for right now, I have a better understanding. Maybe one last question. I heard that it was possible to use a tablet in the timeline and then go back to the TP program for somebody who is usually, I don't know how to say it clearly in English, but
Familiar with the traditional
yeah,
sets?
yeah, more familiar with the TPP programming.
Yeah,
So is it
yeah.
possible to go back and forth?
Yeah, so if you were to generate the program based on the traditional teach pennant style programming, then what that's going to do is essentially put icons into a timeline. So it kind of does it side by side. If you make it with the icons and then you go into the edit screen of the TPP programming, it'll have a list of commands there based on the icons and vice versa. So if you make it on the TPP and then you go to the timeline, the icons will be there.
Okay, with the parameters that you have already put
Yep.
in the, okay. That's
So you
nice.
can do it either way.
Okay. So we don't have any more questions, Felix?
No, I think it's good for me.
Okay.
That was very interesting. Thanks a lot.
No problem.
Thank you.
For the meeting, are you gonna send a video or how does it work or?
Yeah, I'll send you this video.
Okay. Well, we really appreciate it and thanks a lot again.
No problem.
Thank
Thank you.
Okay, thanks a lot. Bye.
Have a good one.
Bye.
Bye-bye.